Good morning, everyone. I'd like to welcome you all to this dual meeting. We have a group here in the Catholic Church Hall in Hermanus, and then we have other people online elsewhere in the country. So this morning we have Stephen Davey presenting to us from Darling. He lives in Darling up the west coast. Stephen is a geologist. Again, he's a UCT graduate. The early part of his career was in minerals exploration. He spent some time, I think it was in Peru, lived on the doorstep of an active volcano, and was involved in base metal exploration, particularly copper. He subsequently came back to the Cape, did an environmental course, and he now works out of Darling, and he does a lot of extensive work in applying for mineral rights, particularly in industrial minerals. For those of you that were here last week, I talked about silica. As we know, it's the year of glass. And this morning, Stephen's going to take the talk I gave, which was general and sort of covered the international scene. And he's going to talk about silica sand, which is essential for glass, and the deposits that we have here in the Western Cape, and particularly on the Cape Flats. So thanks, Stephen. We really appreciate the fact that you're going to talk to us today. And we look forward to another interesting series of presentations that have been all about glass, but obviously the base mineral there, the critical mineral is silica. So today we're going to look at silica here in the Western Cape.
Thank you very much, John, and thank you very much for attending this presentation. As John said, it's the International Year of Glass. And so the Overberg Geoscience Group is very happy to present this basic double feature. So John gave a very nice introduction last week to silica in general, and today we're going to be looking at it more specifically from the Western Cape point of view. On the opening picture, there's a very important reason why we need glass, Darling cellars, and I'm sure you guys need glass for your good wines that you get from the Himalayan Arda Valley. So we're going to be looking at what is silica sand, where is it found in the Western Cape, and then a little bit about Consul Glass, who are the main glass producers here in the Western Cape. Then I'm kind of going to go a bit off topic because we're going to be looking at the Philippi horticultural area and looking at their glass. But it's a really interesting area, and there are a lot of other aspects that aren't really related to glass, but it's quite important to consider because life is not simple, and there's sort of all kinds of angles to Philippi. So Philippi is both an asset, but it's also quite a big challenge. And many people in Cape Town don't even know where Philippi is. And never mind, maybe some of you folk have retired in Hermanus and have come down from the reef and don't really know too much about the Cape Flats, so we'll go into that. And then hopefully there'll be some discussion afterwards. So the definition of silica sand is high-grade silica sand is unconsolidated sand containing greater than 85% SiO2, which is silica dioxide, which is basically quartz, with 99% by weight lying in a grain size range of 0.1 to 0.5 millimeters. So this is fine to medium grain sand. And it's used for lots of things. And the next slide, I think, explains it a little bit better. So where you find silica sand determines how you're going to get it out. So if the sand is dry, then obviously you can just use normal earth-moving machinery, such as excavators or front-end loaders. But if the sand is underwater, then you would need to use a dredger. The sand that comes out of the ground will be raw sand, and so it needs to be upgraded so that it reaches the purity required for making glass. And there's all sorts of things that can be done to the sand to sort it, clean it, wash it, scrub it, take it through services, leach it, etc., take out any magnetic minerals, and so on. And then there's a number of different products that can be made. So you've got glass sand, which we're going to be mainly concentrating on. Then foundry sand for making engines and so on, other industrial uses. And then there's also specialized agricultural sands, sand that is used for top-class football, rugby stadiums, sand that's used for golf courses and so on. The glass sand can also be made into different types of glass. So you've got flat glass, colorless glass containers, and colored glass containers. So here in the Western Cape, the main source of silica sand is actually in Philippi, right in the Cape Flats. And then going up the west coast, there is silica sand near Atlantis, which is mainly used for Atlantis diesel engines. Also of interest because of the Overberg group, there's a small deposit near Kleinmond that was worked years ago. It's not being worked now. And the Council for Geoscience has discovered some other silica sand up near Hopefield in a borehole that was basically a research borehole looking at the cover recent sediments up the west coast. So Philippi is the most important silica sand resource. It's actually been exploited for manufacturing of glass since 1925. They use a form of dredger mining where they obtain silica sand down to a depth of 20 meters, and this has been done since 1956. And there's many people in Cape Town that don't even know that they've got this mine sitting in the industrial area. Actually, nowadays it's surrounded by Athlone industrial area. And the formation geologically is called the Springfontein Formation, and this is clean, well sorted and rounded, fine to medium and medium grained quartz sand. And the average SiO2, that's silica dioxide concentration, is more than 95% in the Philippi sand. Up at Atlantis, the sand has been mined at the one site since 1982, and nowadays it's called Atlantis Foundries, but a lot of people will probably still remember when it was called Atlantis Diesel Engines. And this sand is also sourced from the Springfontein Formation. But due to the presence of the Atlantis aquifer in the area, a lot of the sand won't be accessible in the future. In the Kleinmond area, the glass sand was previously mined on a small scale on a farm called the Dry 563, which is northeast of Kleinmond. It's a relatively small deposit, but it's a good quality deposit, and it originated from the weathering of Table Mountain sandstone. The borehole drilled by the Geological Survey in 1990 to the west of Hopefield encountered silica sand about 10.5 meters in thickness, but the problem is there's an overburden of 16.5 meters of thick sand, which would be building type sand, and it would be very difficult to make this economic because of all the work that would be needed to take the overlying overburden off. And there's not exactly a huge market around that area. A lot of the cost of sand is actually in transport because it's a high volume material. Transport is the big thing. So sand should generally be as close to the market as possible. I did have a video, and it's on YouTube, Consol, the story of glass, on a very short little clip, but it gives you quite a good introduction to how Consol makes glass and the constituents of glass. You will see all the bottles that come out and make all the wine bottles that we need for the Western Cape wine industry.
In the fiery forge of cosmic activity, when Earth itself was forming, nature gave us a substance that today forms an integral part of our lives: glass. When we first discovered glass, it would have been naturally occurring, either as volcanic obsidian or as a result of lightning striking sand. We were immediately captivated by it. Consol Glass has been synonymous with glass packaging for over 70 years and is Africa's leading glass packaging manufacturing company. Join us as we go on a journey through a specialized process to produce nature's packaging. Glass starts its life as raw materials: sand, soda ash and limestone combined in a specific ratio. Elements are added to color the glass. For example, iron results in green glass, while copper creates blue glass. Because glass is infinitely recyclable, Consol incorporates a large amount of recovered glass known as cullet to reduce the amount of raw materials that are used. Cullet also melts at a relatively low temperature, allowing us to reduce emissions and save energy. Raw materials are stored in large silos and delivered to mixers according to strict recipes. Consol uses leading-edge technology to ensure that the mixed material or batches delivered to our furnaces meet our stringent quality standards. It takes around 24 hours for a batch of raw materials to be converted into molten glass. Batches are continuously fed into the furnace, which is the beginning of what is known in the industry as the hot end. For good reason. The temperature of a furnace is approximately 1500 degrees Celsius. From the furnace, the molten glass makes its way to the refiner area, where it is cooled to nearly 1200 degrees Celsius. Maintaining the correct temperature is extremely important, not just to sustain the flow of the molten glass, but to ensure the highest quality of the end product. From the refiner, the four hearts deliver glass to the individual bottle-making machines. Streams of glass are cut into gobs of a predetermined weight, as much as is needed to make a single bottle. These gobs are guided into the individual molds of the bottle-making equipment as part of a process known as forming. Bottles are formed in two molding stages. In the first stage, the gob of glass falls into a blank mold and the opening of the bottle is formed. The final glass container is then formed using one of two methods. The first, known as the blow-blow method, is used for larger containers. In this process, compressed air is blown into the molten gob to create a cavity, resulting in a hollow and partly formed container. This is then transferred to the second molding stage, where compressed air is used again to form the final shape. The second is known as the press-blow method. This time, a metal plunger is used to press a cavity into the gob in the blank mold before compressed air is used to form the final container. Variations in this method allow for either narrow or wide-necked containers to be formed. The newly formed bottle is removed from the mold and transferred by conveyor to the annealing oven or layer, where it is coated with tin oxide to strengthen. Cooled from 600 degrees Celsius to 100 degrees Celsius in a controlled manner, and then sprayed with polyethylene wax to protect the surface of the glass. All glass containers manufactured by Consol undergo multiple tests and inspections to ensure that they comply with strict international safety, health, and environmental standards. The bottles undergo further visual inspection by sophisticated high-resolution camera equipment as well as trained specialists. Once approved, our containers are enhanced to our client specifications in support of their brand building and operational requirements. This could involve further coloring, embossing, debossing, coating, sleeving, decorating, and labeling. With the manufacturing process completed, the bottles are individually coded with production date and time, packed on pallets, covered with protective shrink wrap before being dispatched to our customers. With factories across Africa and a production rate of 1 million tons of glass annually, Consol is well placed to maintain its leadership position and fulfill its vision to be the supplier and packaging of choice across Africa. Thousands of years after it was first discovered, glass remains an integral part of our lives. It is 100% recyclable and 100% impermeable. It's the safe, healthy, and sustainable packaging choice when preserving food, beverages, and pharmaceuticals. So, when you choose packaging, choose wisely. Choose glass. Consol. The best things come in glass.
This is the mine in Philippi that's been operating since 1956. And for most people in Cape Town, this is not your idea of a mine. It's just a dredger chugging along fairly quietly. I don't know if you can really see it, but it's got a name on the side, which is Indlobo, which means elephant. So I guess it's to do with all these pipes coming out of the dredger, which pumps the sand through to the processing plant where the sand is upgraded so that it can be taken to the Consol factory in Bellville. So here's another picture of a mine. Does this look like a mine to you? Devil's Peak and Table Mountain in the background. There's also the Athlone Industrial Area, which houses Peninsula Beverages, which is the big distributors of Coca-Cola and all the cold drinks in the Western Cape. And this is a photo on the other side, which is near the plant. And this sand on the side of the plant is actually sand that hasn't gone through, well, it's basically reject sand that's gone through the plant, and it's not going to be taken through to the factory in Bellville. This is an aerial photograph, Google Earth photograph of the site. And it's quite a sizable site. It's 96 hectares in size. And it's interesting because hardly anybody in Cape Town knows about it. You have the Athlone industrial area on the western side, and then you've got the suburb of Manenberg on the eastern side. So a little bit about the geology. And this comes from John Compton's book, The Rocks and Mountains of Cape Town. And geologists know that the environment has never been static. Things happen, and the sea level rises and the sea level goes down. And the illustration on the left-hand side shows different times when the sea level was more or less 20 meters higher than it is today. And so Table Mountain was an island separated from the mainland. And you had the Cape Flats Seaway, which connected the sea between Table Bay and False Bay. And so you could have movement of water and also deposition of sediments in the bottom of the Cape Flats Seaway. And this has been confirmed. There's boreholes that have drilled, and they've found marine fossils below the Cape Flats, things like shark's teeth. And then you have the other extreme, for example, was during the last glacial maximum, when a lot of the water was actually held in the ice caps in the North Pole and the South Pole. And the sea level dropped to 130 meters below where it is now. And the whole of False Bay was an open plain. So you can imagine when the southeaster howled, how much sand could be blown from False Bay right across the Cape Flats. So there's a whole history of movement of sediments backwards and forwards. But obviously this deep channelway, the Cape Flats Seaway, that's the area where sand could have been cleaned, washed, and repeatedly washed again. You know, that goes a long way to explain why the best sand is found in this channelway. This is a simplified geology map of the Cape Flats, and this comes from a Geological Survey Bulletin 69 by Hill and Turon in 1981. And the area with showing the higher grade silica sand goes through the middle, and you can see it's pretty much in line with the deep channelway that was shown on John Compton's map. And they knew about the Philippi area back in the 1960s, and the area that's outlined with the red line was proclaimed as a protected area in terms of the legislation at that time. And it was to protect the silica sand and to protect the area for agricultural purposes. This is a map that was prepared by Dr. Doug Cole from the Council for Geoscience, and this goes into a little bit more detail on the Philippi area. And maybe what I should do is just point out a few features, because even many people in Cape Town aren't that familiar with it. But when we look through the different maps, just bear in mind that Sikuflay is on the left-hand side. It's a big, well-known flay on the western side of Philippi. There's a road called Strandfontein Road, which is sort of like a north-south road, and it's got quite a sharp bend before it turns down towards the coast. The road along the coast, you might know, is Baden-Powell Drive. You can turn off somewhere past Somerset West and then take Baden-Powell Drive and go all the way to Muizenberg. On the northwestern side of the Philippi horticultural area, you can find the Macro and Ottery hypermarket. And some of us that are a bit older might even remember the old Sunset Drive-In, which was situated more or less in the top western corner of the Philippi area. What this map also shows is the two different types of sand. You have building sand, which occurs in the overlying dunes, and then you have glass sand, which is basically below the surface. The building sand is shown in yellow. However, most of the building sand has been used up. There's still a remnant in the eastern corner of the Philippi horticultural area, closer to Mitchell's Plain. There is some building sand on the western side, but this is all included in the False Bay Nature Reserve, which is a proclaimed nature reserve that's run by the City of Cape Town. What this diagram also shows is the Old Council for Geoscience boreholes, which are numbered basically A, B, C, D, E, F, G, etc., throughout the area. And in the deep channelway, you will see a borehole marked C, and it's got a thickness of 32 meters. So there's 32 meters of silica sand at that particular borehole, and borehole D has got a thickness of 24.4 meters. The current Consul glass operation is a little bit to the north of the current Philippi horticultural area, because the Consul glass mine is now pretty much surrounded by factories and in the industrial area. It's no longer surrounded by a farming area. So just to summarize, the Philippi horticultural area used to be the principal supplier of building sand, but the remaining deposits are just limited to the southeast, and they're mainly sterilized due to a purchase of land by a property developer, and I'll go into that a bit later. But generally for building sand, the mining is permitted down to not lower than the general surface level of the surrounding area, and that is so that there can be a sustainable use of the land after mining the building sand, that it can be used for growing vegetables for horticultural purposes. The silica sand deposit that's situated in the central channel, this is the unmined part of it. It's just a deposit, and it's referred to as there are no comparable deposits anywhere else in South Africa. It's a major resource, 15 meters in thickness and about 315 million tons of high-grade silica sand. This is a north-south cross-section. There's some vertical exaggeration, so the topography is not exactly as severe as shown in this diagram. So this is from False Bay on the left, from Strandfontein, going straight towards Cape Town on the right. And the overlying sand in the more modern dunes is referred to as the Witstrand Formation. And this is typically the formation that is used for building sand, and it still contains seashells. So it could have about 20% calcium carbonate in the Witstrand Formation. Whereas the Springfontein Formation, which is the underlying formation, this hosts the silica sand. And most of you might know that the groundwater in the Western Cape tends to be slightly acidic. And what has happened is that the groundwater basically dissolves all seashells in the sand, and it also helps to purify the sand so that you get a much cleaner sand in the Springfontein Formation. So this is the proclamation of 1968. So even in those days, they knew that this was a valuable piece of land. So it was stated that the proclaimed land near Philippi may be used only for the purpose of agriculture and or mining and beneficiation of silica, in 1968. A more detailed report was written by Helen Turon, a Geological Survey Bulletin, and it was described as one of the best deposits of its kind in South Africa. Unfortunately, this proclamation fell away in 1991. And subsequently, whenever you read about Philippi, the focus tends to be on the agriculture, and you hardly hear about the mineral resource in the Philippi area. And I'll also show you that there's varying and more competing interests of different people as time goes on. This diagram illustrates from the top left to the bottom right the pressure on the Philippi area and how actually ends up shrinking with time just because of the urban pressure all around it. From 1968, I think it was about 3,000 hectares, and each time somebody nibbles off a chunk of it, to getting to the stage on the bottom three diagrams where you can see the area in the southeastern corner, which has been taken out by the Rapicorp transaction, so that you end up with a very reduced Philippi horticultural area today. This is an image from the city of Cape Town. It's a photogrammetry, it's not a satellite image, it's aerial photographs. But maybe what you should just focus on all of these pictures is I tried to keep Sikuflei on the left-hand side so that you can use it as a marker. And Strandfontein Road is the sort of almost north-south road with the kink that goes down towards the coast, and along the coast here, this would be Strandfontein and Badenpaal Drive. But in 1938, you can see that this is pretty much a wild, undisturbed dune country, and there are a few plots and small holdings up on the western side near to Sikuflei, but really nothing much else going on in this area. Then in 1973, you can see that the horticultural, agricultural area is slowly creeping into the Philippi area. Again, you can see Sikuflei on your left-hand side, Strandfontein Road coming down. You can't really see the kink that clearly on this picture, and the coast, Strandfontein and Badenpaal Drive going along the coast. And this is a picture today, so you can see how much has changed over time. We have Sikuflei on the left-hand side. Just below that is the Cape Flats wastewater treatment works. Then we have Strandfontein Road, the kink quite clearly shown. There's a new village called Strandfontein Village, which is between the Philippi area and the coast. And the bottom right-hand side is the Mitchell's Plain wastewater treatment works. And on the right-hand side is the whole town of Mitchell's Plain. And the central area, you can see all the farming land of the Philippi horticultural area, apart from this block, that's the remaining block in the southeast of the Philippi horticultural area. As I said before, the building sand is running out. This is what John Bristow was explaining last week. Quite a lot of sand is now being mined from the Macassar area, so this is an alternative source of building sand. Obviously, to get sand to Cape Town, it makes the transport much more expensive going to Cape Town. Here are some photographs of the Philippi horticultural area, and again, familiar picture of Devil's Peak and Table Mountain in the background, and these quite amazing fields full of all the goodies that we buy from Woolworths: cabbages, lettuce, carrots, right in the middle of Cape Town. And you can see some pictures on the right of, these are still some of the last remaining little dunes, and a lot of the horticultural land actually couldn't have occurred unless the overlying dune sand was mined to bring the area down to an area where it would have been possible to farm it. So sort of literally the farmers and the sand miners have sort of been working hand in hand. As this building sand is removed, then the farmers can come in and create the horticultural land. It's actually a very nice situation where you can do the mining and you create a sustainable use afterwards and rehabilitate the area very nicely. This is another example, and so you can see in the foreground is freshly rehabilitated land, which they are now turning into cultivated land. There's a remaining small dune that's basically like a little island, and it's surrounded by horticultural land. This is another picture, and pretty much there used to be a dune all the way along from the bottom of this picture right up to the north, past this area with the shade cloth. And that whole area has been converted into horticultural land, and it wouldn't have been possible if the sand mining guys hadn't taken off that dune. These little ponds are ponds that the farmers create for pumping water in and then using for irrigation. And the big advantage for the farmers in the Philippi area is that they're never short of water because it overlies the Cape Flats aquifer, and they are able to get 3 or 4 crops a year in the Philippi area. There was a socio-economic agricultural plan prepared by the Western Cape Department of Agriculture in 2018, and just summarize the vegetable growing significance of the Philippi area. This is a combination of climate, water, and soil. The water is nearby. Because of False Bay, the temperatures in summer are slightly cooler than a lot of other areas, which can get pretty hot in the Western Cape, but you've got the southeaster blowing off False Bay, and it just helps to keep the temperature down a bit. They can get 3 to 4 crops per year out of the area, and they can get between 400 and 800,000 turnover per hectare per year. The vegetables are used to supply both formal and informal markets. And it said that for every 1 million rand spent in the vegetable industry, 4.6 direct jobs are created and 46 indirect jobs created. During the drought, this was a 2018 report, Philippi just carried on producing vegetables, so it helped create resilience for Cape Town during the drought. And basically, they said that it's irreplaceable, Philippi horticultural area within 120 kilometers of the city radius to provide the veggies for Cape Town. This is just a nice picture. It's one of the farmers, JJ Blanche, and he employs 400 people on this farm. Traditional area actually where there were a lot of immigrants that came, I think at the end of the 1880s from Germany, and been the backbone of the farmers in the Philippi horticultural area. So there's a lot of German names like Rix and Horstmann, for example, in the Philippi area. You know, the thing is that farming has to be really done well to successfully get 3 to 4 crops a year. So, well, this was a vision, I think, that came out of that 2018 report, just sort of trying to highlight all the benefits of the Philippi horticultural area. But as you can see, it's all pretty much focused on Philippi providing food and Philippi being a green area for the city of Cape Town. Then recently, with the drought, and we've had a few presentations in the Overberg Geoscience group from Umboto and other hydrogeologists, the importance of groundwater. It's really taken a long time for Cape Town to appreciate it, but they've sat up and taken notice, and they're looking very hard at the Cape Flats aquifer. The Philippi area is located over the portion of the Cape Flats aquifer with the greatest groundwater potential, and they estimate that they can get 26 billion litres per year from the aquifer. However, it's under pressure from urbanization. You know, they built the Mitchell's Plain wastewater treatment works right on top of the aquifer. They didn't really think about these things in those days. However, the water quality is still good for agriculture, and there is sufficient water available for expansion. And there's a project on the go at the moment, the abstraction and treatment of groundwater from the boreholes, which many of them are about 40 meters depth. They're also going to be recharging it with highly purified wastewater just to ensure that it doesn't get drained and sustainability. It's not the first aquifer scheme. There is another aquifer scheme that's on the go in Atlantis. So the city already does have experience of managing aquifers. The project under construction, and phase 1 is going to produce 20 megalitres per day. And this is an aerial picture, actually looking southwards towards False Bay. That's sort of the Simonstown area in the background. But you can see here's a water treatment plant for water that's being abstracted from the Cape Flats aquifer area. And you can see Just in the foreground, there's some fields that have been recently established, and this is also a rehabilitated sand mining area in the lower right-hand side of the picture. Heritage people are also interested in the Philippi area, and there's various brochures that have been put together, and Heritage Western Cape is thinking of declaring the Philippi area as a cultural landscape. This is all well and good, but you know, each time one of these authorities places a layer on top of an area, it actually means that there's an added layer of bureaucracy on top of what anybody plans to do or would like to do to navigate your way past. The city of Cape Town has also mapped the whole city, and this is the spatial development plan, but it also includes what they call the biodiversity network. And the biodiversity network are meant to be all green areas or remaining natural areas in the city. And this is also an added obstacle that whoever plans to do whatever type of activity, you know, has to navigate your way past. You have to undertake botanical studies and actually look at what the condition of the ground is to try and get permission for whatever you need to do. On the left-hand side of the Philippi horticultural area, these other green areas are already included in the City of Cape Town's nature reserves. And that actually is the best way for the City of Cape Town to protect the green areas, is to incorporate them in nature reserves. Here's a number of things sort of summarizing the role of the Philippi horticultural area in the city. So we've got food security, we've got water security, we've got economic benefits to provide employment, farm laborers doing packing, picking, sorting, selling. There's also cut flowers that are grown in the Philippi horticultural area. There's still some limited building sand that's being produced in Philippi. And then you've got the silica sand deposits, obviously. This slide just shows there's a number of challenges, and you can see the orange areas on the outside are where urbanization is busy squeezing into the area. Up in the north of the area, the Lansdowne Road industrial area, there's now a lot of warehouses for Spar and for Pick and Pay and so on. Sort of probably quite convenient for the airport as well. On the eastern side, between Mitchell's Plain and the Philippi horticultural area, is an area called the Beltapurian Wedge. And unfortunately, there's a massive informal settlement called Sikala that's developed on that area. The Rapicorp or Oakland City site on the southeastern corner of Philippi, I'll go into that a little bit later. And then on the western side, there's a number of small holdings and also informal settlements, and these are also tending to kind of squeeze their way into the horticultural area. There are also other issues, including crime, cable theft, illegal dumping. So there's quite a few challenges associated with this area. This is an interesting story, and it summarizes a little bit of what happened. Is that land that was bought by Rapicorp was 480 hectares that was bought for about 36 million rand. And he made a lot of money, and he persuaded pension funds, including, I think, Kusatu and Satawu, to invest in it because this was going to be the latest and greatest thing, and they were going to develop it into housing and so on and so forth. Many of you might have come across Bruce Cameron. He writes pretty solid articles in a little magazine called Personal Finance. I think it's included in some newspapers. And basically what he was saying is, when you are a curator of a pension fund, you shouldn't invest people's money in speculative ventures. And this is what these pension funds have spent a lot of money on property that didn't have mining rights, and it didn't have property development rights. It's a scheme where a few people made a hell of a lot of money, and now this company used to be called Rapicorp and is now called Oakland City, still struggling to actually get the development rights to build a little mini city down in that corner of the Philippi horticultural area. The socio-economic agricultural plan kind of summarized what they would try and do to the area. It looks like they've more or less accepted the de facto situation of what it is, but obviously trying to protect the area. What they're also trying to do is to kind of get an intergovernmental approach to look after this area, to get the city, province, law and order, the farmers, the community all together, because at the moment, sort of like a whole lot of cats in a bag, all pulling in different directions, and nobody taking a holistic control of the area. Then you've also got the other actors, or the civic activists, and there's a group that call themselves the PHA Food and Farming Campaign. And they say that the massive Oakland city development could destroy farming on the land and dry up the aquifer. They've actually been very successful. They've actually managed to persuade environmental lawyers, very well-meaning people from Cape Town to support them. I also don't agree that this area should be developed for housing and covered in concrete and tarmac and stuff. But on the other hand, it's sort of a little bit stretching the point to say that the Oakland city development could destroy farming on the land, because that land is fallow land, that there's been no farming on it at all. So you have this type of situation. And the other examples in South Africa where you have environmental activists coming up with the cause, and then you've got groups of people that who would never really join together saying, well, our enemy is a sort of a mutual enemy, so let's all get together and do it. But this particular case, it could be maybe a noble intention, but I don't think the people realize that it's not 100% the truth. So you have the campaign, the Philippine Food and Farmers Campaign, and they've got sort of the latest buzzwords: small-scale farming, regenerative farming. They're saying that the area is farming area. Actually, when you look at this Rapicorp area, you can see there are no farms on this area at all. It actually consists of dunes. There's a lot of tracks in here. Unfortunately, it's quite a neglected tract of land. And unless the dunes were mined, you couldn't farm on this land. So it's quite a tricky situation. And the problem is it's private land. So if the city had wanted to proclaim it as a nature reserve, well, they should have bought it, and then they could have developed it as a nature reserve. But now it's private land. These people that claim they're from the Philippine Farming Campaign, not many of them are actually real farmers. But I think what they're angling at is that somebody in the government is going to buy the land and then dish them all out some land. This is sort of not really a type of area where you can do small-scale subsistence farming, because the soil is not that nutritious. I explained that we know that it's mainly silica, so you need to add a lot of compost to try and farm this land. So it's quite a complicated situation. Now, this is an aerial photograph, and this is looking from the Mitchell's Plain side towards the False Bay side. There would be sort of Muizenberg in the background, and these are farmlands which used to be mines. And I'm quite pleased to say that my clients have managed to get a closure certificate from the Department of Mineral Resources for a mine on this land. And it's quite a very rare thing for the department to issue these, but when a mine looks like this, it's very difficult for anybody to complain about the rehabilitation. So this is the rehabilitated sand mines on the right-hand side, and on the left-hand side, this is the undeveloped land, which is the Rapicorp area that you can see on the left-hand side, that the Philippine Food and Farming activists are saying that basically they want a little slice of this. And this is looking towards the south. You can see False Bay in the background, and this also shows you the Rapicorp land with the edges of the sand mining areas on the outside, or that are now converted into horticultural land. So that's basically the end of my story. There's Table Mountain in the background, horticultural land, and a little remnant pocket where some sand mining is taking place. So I'm not sure if there's any questions or any discussion.
Thanks, Stephen. And I see there a bunch of messages. Are you going to look at your chat box and see if there's anything you need to answer for a start?
Okay, let me just have a look. This is precious. When I kicked off on kaolin and sandstone on a geological survey with Dr. Hannes Teron, also spent time there. Okay.
Got a few hands up in the hall here, Stephen.
Thank you, Stephen, for an interesting talk. A couple of points came to mind. The silica deposits in the Western Cape. I recall years ago, further up north, I think the most north you showed on the west coast was Hopefield. There was a large silica processing factory at something called Namakwa Sands. Is that still in existence? Is that deposit still viable? Because I believe there's quite an international interest in that particular factory and the development of that silica sand. So that was the one question. The other one was, I'm very interested in the rehabilitation of the mined out areas where the silica has been removed. How do they produce that kind of quality of vegetables and various other things that are produced in that agricultural land? What is the content in terms of organic matter in that sand or in the rehabilitated area? Does it contain the vital elements of plant growth, which are nitrogen, potassium, potash? Or does that have to be introduced to enable that amazing plant growth and productivity?
The first question is, yes, Namakwa Sand is definitely operating up the west coast. Namakwa Sand is producing heavy mineral sands. So they're not producing silica sands, but I think it's probably the biggest mine in the Western Cape, actually, Namakwa Sands. And it used to be Anglo-American, but the new company is called Tronox. It's all a very, very important company in the Western Cape. Then the question about the fertility in Philippi for rehabilitation. There are some very big producers of compost. I think Master Organics is in Strandfontein Road, and they've got a massive area where they're continuously producing compost. And the farmers definitely need to add compost to the land. As I sort of tried to explain that Philippi, it's almost like a gigantic hydroponic system, because you've got clean sand and you've got water, but you need to add the nutrients. And I actually remember once upon a time, the gentleman from the Philippi Farming Campaign gave a talk at the Athenaeum in Rondebosch about their campaign, and he was explaining how fertile the soil was in the Philippi area. And an old friend of mine, Barry Lowe, who's a botanist, a very good botanist, that knows Philippi like the back of his hand. Unfortunately, he passed away, he's no longer around. But at that meeting, Barry Lowe put his hand up and he said to them, listen, the Philippi sand is not fertile. You know, you must understand that it really isn't fertile. And the guys from the Philippi Farming Campaign, the activists, sort of more or less refused to believe him. No, you definitely need to add compost, and that's why those big compost producing people like Master Organics are needed in the Philippi area.
Okay, just on the first one, Stephen, for interest in going back to Ed, we have in the room an ex-Anglo-American geologist here, who I think Graham Palmer, you were involved in the discovery of Namakwa Sands, you and Peter and so on. Come and tell us about it. So that's Graham Palmer, one of our local
I was
a geologist
working for Anglo-American based in Cape Town, and we discovered the deposit in 1986-87. It's a huge deposit. There's a lot of black sand along the beaches up there, but we weren't allowed to develop those, which they are doing nowadays. So we had to go 50 meters, 100 meters onshore, and we drilled boreholes and found deposits in quite low grade for 30 meters, but with 2 strand lines with black sand in them, which is the titanium. And that was, the mine started in about 1991. And I visited again 3 or 4 years ago, and they discovered an extension on the north, and they said it's still got another 20, 25 years. As Stephen said, it's not a silica mine. They don't produce silica sand. They take the heavy minerals out, and then they just put the waste material back where it started, so that it's rehabilitated.
Stephen, and you showed it. Our Cape Flats was once underwater, and Gillen here is asking about, exploration for silica sand under the sea. I guess there it becomes an issue of, stability and being able to mine in an active marine environment.
I'm not sure if anybody has explored for silica sand under the sea. I really don't know anything about that.
Certainly around the world, people, will mine, like you're seeing there in the ponds. Mining in ponds is actually quite inexpensive. So mining in lakes and in the environments where you won't necessarily have, say, sand on land, and you can go and get it out of a lake, for example, will certainly be feasible. We forget to, going back to what Graham's saying, Graham Palmer, we have these real extensive heavy sand. It's a heavy mineral like diamond. So these heavy sands, titanium, what else, Graham? Monazite, rutile, all the pigments that go into paint typically come from these, they're old beach deposits. The beach has, moved, you walk on the beach often, you get a black sand layer, which are the heavy minerals being pushed up by the high energy Richards Bay mining on the east coast of Natal, KZN. Again, is a very extensive, heavy sand deposit. All our diamonds that we mine on our west coast and on the Namibian west coast were all diamonds that came from inland down the Orange River, and then they were reworked onto ancient beaches on our west coast, and we mine those deposits. So, water and forming sand dunes plays a very big role in the formation of mineral deposits. I think it just goes back to what you're talking about, clean, fresh sand, and it's very well sorted. It drains wonderfully. If you add organic material to it, it makes a great growing medium. Many of us have pots for particular plants like cycads and so on, where you basically get nice clean sand, and then you add whatever nutrient to it. It doesn't become waterlogged. So, good old silica sand has many uses, not just for making glass.
There's a comment here from Jean. Just think that the PHA area can be well developed regeneratively using high density farm animals. This can utilize the grass for productive use and open up soil for recharge. At later stage, mining can proceed when required. The animals are herded, planned movement planned, and only returns once grass completely recovers. This will reduce sharp topography, dung, urine, etc., increase organic content of the soil, which further increase water holding capacity. At the moment, there are farmers in the Philippi area. There's pig farmers, there's cattle farmers, and I'm sure all of that manure is used, obviously mixed up with the compost. I'm very sure that they are using that material from the animals. Unfortunate thing is private property. So you're talking about land that belongs to different people. And so if the land doesn't belong to you, you'd have to go and persuade whoever the landowner is what to do with that land. In a way, the city of Cape Town missed the boat, because if they wanted to have proclaimed it as a nature reserve, then they should have bought it when they could have, when the land was fairly cheap. And your sand miners also missed the boat in that southeastern corner, because they wanted that resource and they wanted to have secured it, then they should have bought it. So now you've kind of got like a de facto situation where the land doesn't belong to the state. It belongs to a private company that is struggling to get development rights for something that a lot of people don't want it to do. So a lot of things floating in the air.
A very interesting talk. I enjoyed it all. Just one question though. You showed a picture of the dredger operating, and the area in which it was operating was surrounded by buildings, people, homes and whatever. How close to the edge of the homes, in other words, the boundary, is the dredger able to go? I mean, because there's going to be an angle of repose, which is very, very flat under that water.
I understand that Consul is checking on the boundary, but I would guess that some of the roads are a bit too close, especially on the western side, which is the side with the factories, with Peninsula Beverages and so on. From the top of my head, you've got the width of the road, then you've got a fence, And then there's probably just another 10 meters or so before you get to the edge of the excavation. I would think nowadays they wouldn't allow buildings to be so close to the edge of it, but from what I understand, Consul is monitoring it, and it's pretty stable all the way around the edges of that excavation. I would guess that if they were concerned about a certain area, then probably what they would do is they would pump sand that had been screened and is not suitable to go to the glass factory, and they would just pump that extra sand back into any areas that they thought maybe needed extra support.
Thanks, Stephen. And perhaps just to wrap up, and you can have the final parting shot. What fascinates me, and we should all be aware of, is that aerial photograph you showed of 1938. That's 84 years ago. So it's in a lifetime that Stephen showed the Cape Flats, relatively unspoiled, and you see what we've done in a person's lifetime. And where does that stop? And how do you look after that environment with all that informal housing? Where does the sewage go and the wastewater? Obviously, there are 2 sewage works on the Cape Flats, but where does the wastewater go? Where does the sewage go? And it's the same sort of challenges that we face in Hermanus. We have a world-class water system. If we look at what's going on in Gateway, we are polluting that area. And we have an overpopulated Silica township, and we have a good sewage system, but where is all that other sewage and wastewater going? And it's something, in this Western Cape that our planning people and developers really need to take note of. And Stephen and I are both converts. Our point is that every single municipality in this Western Cape and anywhere, for example, we saw the disaster in Durban. A lot of the disaster in Durban is caused by building lack of maintenance on soils that should never have been built on. So, town planners really need geologists, and they probably today also need geohydrologists as part of the management team. Okay, maybe you can wrap up, Stephen.
Yeah, 100%. John and I are totally on the same page, and fortunately, I understand the city of Cape Town has got hydrogeologists nowadays, but definitely they needed more all over the place. Nothing else to say, really. Thanks very much for the opportunity, and thanks, John and U3A.
Thanks, Stephen.